Hey everyone, welcome to another Oxygen webinar. Today we'll be going over Oxygen 7.4. Within this release, we'll be going over the new features such as the Oxygen Net improvements, the redundant master mode, multi-master mode within that, the modal test improvements such as the SDOF Circle Fit and the video export for modal shape animation. We'll be going over some new instruments, the orbit plot and polar plot and how they work, as well as some chart recorder improvements, text instrument improvements, power improvements as well, and a couple new Skippy commands and a couple other things as well. With that, let's get right into it. So with the release of Oxygen 7.4, there have been some Oxygen Net improvements. We have a redundant master mode. What this does is it shows the measurement nodes that can be distributed to multiple master clients simultaneously across a single or second redundant network in case the node has multiple LAN ports. And in case one master client or network fails, the remaining clients can continue recording, ensuring no data loss. With the redundant master mode, OxygenNet supports multiple master clients within a single system, allowing the measurement nodes to be configured from various master clients. Additionally, each master client can record data independently with different recording options. To use these functions, you will need the optional license feature for it, labeled here, right here at the bottom, on each measurement node and master client. And right over here, we have a brief topology of what that would look like. With the modal test, we now have the SDOF Circle Fit theory. This shows the numerical method to estimate the natural frequency and loss factor. Certain spectral regions, such as depicted right over here, where one natural frequency is assumed, is then transferred to a Nyquist plot. The data in the Nyquist plot is used to interpolate a circle. So on the x-axis, we have the real values versus on the y-axis, we have the imaginary values. And the circle is going to be depicted as a frequency domain. So we have a discrete signal here, a discrete signal here, and a discrete signal here as well as some others along the small ticks. When the positions where the curve crosses the y-axis represents an exact natural frequency. So right over here, we can assume where the x and the y intersect. We can assume that that's where our resonant frequency will be. If we also have within the natural frequency two exactly known frequencies, their angles can be used to determine the loss factor. So we have two other known frequencies here, and based off of their angle, we can then use these math functions to determine the loss factor. When using the single degree of freedom, the spectral region of interest must only contain one natural frequency. If it's within the circle and then you see like a small other circle or like another curve begin, you automatically cannot use this function anymore. What this looks like in use is we have our spectrum analyzer here, showing our amplitude and a phase shift over here, which can assume shows a resonant frequency. And within the Nyquist plot, we have our signal being plotted right over here. And where the X and Y intersect, we can see that the natural frequency would be 260 hertz. If we were to move our cursor to, let's say, another area where there might be resonant frequency, there's more than one natural frequency in here. So we get this slight curve, which means we can't use this function at all. This again is depicted right over here with the solution and use of it. So the Nyquist instrument is used to visualize and calculate the circle fit. The frequency bandwidth selection is where you can enter center frequency manual or select it via cursors, which is what I showed earlier in the spectrum analyzer. The single cursor method shows and lets you select the frequency range of interest with one cursor, and 10 bins below and above center frequency are used per default for circle fit. Same when using the manual frequency. We also have the dual cursor method where you can use two cursors for the upper and lower, and the center frequency is automatically the middle frequency in the selected band, as well as a triple cursor method where three cursors are used to select lower, center, and upper frequency, and asymmetrical range selection around center frequency is supported. We do have two different fitting methods that can be chosen within the instrument properties, which is the center only or center or radius. Resulting natural frequency and loss factor is going to be depicted as hertz, and the loss factor is going to be percentage, and it'll be displayed in the table, which can then be copied to the clipboard. We also have a screen template available for it, and to use this function does require another license feature for it. Again, with modal test, we now have video export. With this, we have the possibility to export the modal shape animation as video for reporting. The option is included in the modal test instrument, and the option to define the number of animation cycles is 1 through 10. And we also have the option to export the instrument only or the entire measurement screen in MKV format. This will be available in play mode. So if we go back to our file, and over here we have our modal animation. If we open the instrument properties, you can video export section right over here with the animation cycles 1 through 10. Just exporting the screen or the entire screen, and then you would just hit export. Moving right along, we now have the orbit plot and the polar plot. These are two new instruments which can be found again in the Instruments tab under Miscellaneous. So the polar plot would be depicted here, orbit plot right here. There are no new math channels for it. This will be available in live, record, and play mode. And the orbit plot shows visualization of shaft movement, for example, in bearings, and it shows two motion inputs, X and Y, and 90 degrees shifted, speed and angle, and multiple orders. The polar plot shows visualization of amplitude and phase of X or Y movement, and we'll get into that in the next slide going on. So for the orbit plot, the factors for rotation orbit is resonance above or below the operation limits, the imbalance, which is unequal mass, fluid-induced instabilities, fluid and shaft interactions, misalignment, flexible couplings, and rub, which would be the rotor and stator. So within the instrument, we have a couple different properties that can help depict what is shown on these instruments. So for clearance, you can set the range and limit of the plot. So for example, we have 50 right here and the limit of 90%. For the general, we have clockwise, counterclockwise, or clockwise for documentation. We have the raw and averaged orbit. This is used to show X and Y motion, live movement of the shaft center, average of rotation movement over X rotations, and the centerline plot, which is going to show the X and Y angle and speed, and as well as a snapshot of movement center every X amount of RPM steps, and the filtered orbit, which is going to show the extracted orders from the OA and angle, as well as the filtered live movement for the shaft center and multiple orders. To use this instrument, you again will need an additional license option. For the polar plot shows extracted orders from the OA, displays either X movement and the amplitude as a radius and the phase as an angle. It shows maximum movement in X direction for selected order, and it shows the phase lag to speed for the selected order as well. The snapshot movement and phase is based on the RPM steps and the time steps included as well. Your channels will be shown right here, and the data will be depicted right over here, um, and that's how it works. 7.4 also comes with chart or chart recorder improvements. This will give you the possibility to add up to 10 time markers in the recorder or chart recorder. This can be added via the click in the recorder button or in the instrument properties, renaming and time shift supported, and the possibility to copy data table to clipboards. And this can be available in live mode if you're frozen, record mode, or play mode. What this looks like is we have a chart recorder right here with some simulated signals. If we open the properties menu, we can go over to marker section and make sure we're in freeze mode and add again up to 10 markers, as well as split the cursor into columns from 1 to 4 columns. So if we add some cursors here as well. Visible columns would be labeled right over here, 1 through 4. And those are the new improvements for that instrument. We also have instrument improvements for the text instrument. This gives you advanced text formatting options to format only certain words or characters instead of the entire text. It must be enabled via the checkbox in the instrument properties. For example, if I wanted to make sure that the measurement word was in bold, I would highlight the word and whoops, whoops. You have to select allow advanced formatting, and then you can go ahead and make changes to specific words within your text instrument. So we have line break, uh, italic styling, bold font, pre-formatted text, subscript, and superscript. And this can be drag and drop via instrument properties as well. For power improvements, we have relative harmonics update. This gives you the possibility to calculate relative harmonics either with reference or fundamental values or nominal values. Up to now, fundamental value has been used as reference, but you now have the option to select nominal values as a reference as well. Selection applies for voltage and current harmonics as well as for interharmonics. To enable this, you'll go to your data channels and go to the settings of your power group. Once in there, you'll make sure you're under the harmonic settings for the advanced settings and enable the relative harmonics. And you can select if you want it to be based on fundamental or nominal. So with new features comes new Skippy commands as usual. This time around, all of these Skippy commands will give you the possibility to query data, query detailed information about the sync in and out settings. And these will be the code input commands. I'll give you a second to re-look over those before moving on. I'm not going to go through every single one, but if you do need to a refresher of your Skippy commands, you can do so by referring to the Skippy Technical Commands Manual on our website. We also have new reporting um, settings. We now have added A5 and A6 size to the paper selection dropdown, and we've removed the DEWETRON footer icon from the default pages. So as you can see, if we come to our reporting pages, there's no more DEWETRON watermark. And if we fully open our reporting page, we now have the A5 and A6 paper size for selection. Again, moving on, we go into some miscellaneous updates. These are again going to be used to make everyday use easier and small tidbits to make testing go a little bit smoother. This go around, we have the saturation meter. We have a reset button available in instrument and the possibility to reset the saturation data on all channels via the control instrument. So to do this through the saturation instrument, we'll double click or open the instrument properties. And under saturation data, we have reset assigned channels or reset all channels. So if we go ahead and click that, it can reset. Again, we also have the option to do it via the control instrument. If you remember, we had a new instrument last release, and it was the control instrument, which can be found in the Instruments tab. You would drag and drop that onto here, and under the Instrument Properties tab, you'd make sure you change this control type to saturation data. And once that's done, you'll be able to reset all channels on the saturation meter. We also have the advanced counter. With this, we'll have the two-pulse edge separation mode supported. This will measure the time between a rising edge on input A and input B, as well as being able to refer to the Trion Technical Reference Manual for more details. Option to assign entire systems or boards to one instrument via drag and drop instead of a single channel only. What this looks like is if we were to bring out, let's say, a digital meter Instead of dragging and dropping one instrument at a time, we can go ahead and drag and drop the whole card, which will populate the whole channel list on that card. The next couple of miscellaneous ones we have available are bridge balancing on the Tryon 318 multi-series cards, the possibility to enter shunt target value in engineering unit when sensor scaling is active. Math FFTs show the possibility to reduce complex FFT channels to specific bins. The amplitude and phase channels include specific bins only. This will result in lower RAM and CPU storage and usage in case many FFTs must be created. For configuration lock, no more acquisition restart in case channel list is locked and channel list is opened. So as you can see, if I were to open my channel list and then close it, it says acquisition restart. Once you reconfigure the lock, you can prevent that from happening just in case you don't want your acquisition to actually restart. Moving on, we have bridge balancing for the next stack and the MSI STG, which is going to be supported. Simplified XML setup for screen template can be defined and loaded. DMD files include information about DMS files that were used for the measurement, and that info would be available when opening a DMD file, and the possibility to toggle design mode with the middle mouse button. And the last couple miscellaneous things we have are the firmware versions stored in self-test results in the XML file, DEWETRON Explorer view log displaying the application log, Trinet 3 ICMP and ping extension for systems blocking UDP broadcast. Tryon API, we had a fix for 3-wire RTD resistance settings and gain for the 18 multi-boards. Tryon Power has a fix for spikes in measure samples when using the Tryon sub XV. And we removed a 32-bit driver for Tryon and DEWE2s, and as well as removed the Tryon SDK from installers. If you're going to look to be using that kind of stuff, we ask that you please use GitHub instead. And with that, we do conclude the webinar for 7.4. If you do have any questions, feel free to reach out via email, and we can get back to you shortly. And if you haven't already, you can go ahead and scan the QR code to follow us on social media. Once this webinar does end, there will be a slight survey. If you could stick around and answer that as well, that would be great. And that being said, I'm Christophe Langell, tech support at DEWETRON, and I'll see you in the next webinar.